In the core exams, there is a high probability of finding a question on calculating side lengths, areas, or volumes where the shape of a triangle is involved. Depending on the type of triangle and the information we have about it, we can apply different methods to solve such problems, and this is what I will be explaining in this video. Here is a diagram showing the different methods we can use to calculate the area or the length of a side of a triangle, depending on whether it's a right angle triangle or a non-right angle triangle. We are going to start with the area of a triangle. We have three different cases. If it is a right angle triangle, meaning that there is an angle of 90 degrees, we can apply the formula base times height divided by 2. If we have a non-right angle triangle, but we know the height, the perpendicular distance from a vertex to the opposite side, we can still apply the same formula, base times height divided by 2. But if we have a non-right angle triangle and we don't know the height, we need to use other methods. These are the two methods that you can use in this case. The first one is Heron's formula. We can only apply this method if we know all three sides of the triangle. We need to label each side of the triangle with a lowercase letter, A, B, and C. To be able to apply this formula, first we need to calculate a number that we are going to call S, and this is the sum of the three sides, A plus B plus C, divided by 2. Once we have this number, we can find out the area with this formula. We have to substitute S with the number we have calculated before, and A, B, and C with the three sides of the triangle. And this is the second method, and this is the formula. To apply it, we need to label not only the three sides of the triangle, but also the angles. We will label each angle with a capital letter, and it will be the same as the opposite side. For example, this will be capital A, this will be capital B, and this will be capital C. We can apply this formula if we know two sides and the angle between them. Now we will continue studying the different possibilities to calculate the length of a side of a triangle. We will start with right angle triangles. The first method is Pythagoras theorem. We will be able to apply it if two sides are known. If we know A and B and we want to calculate h, which is the hypotenuse, the side opposite to the right angle, we can apply Pythagoras theorem directly. H squared, so hypotenuse squared, equals A squared plus B squared. So h will be the square root of A squared plus B squared. If we want to calculate any side other than the hypotenuse, we will need to rearrange the formula. For example, if we want to calculate A and we know B and H, we will have to rearrange this formula so A will be on its own on one side of the equation. If we minus B square both sides of the equation, we will have that A squared equals H squared minus B squared. If we want to calculate B, we will do it in a similar way. So rearranging this formula, we have that B squared equals H squared minus A squared. The second method we can use with the right angle triangle is trigonometry. We will use it if one side and one angle is known. When we use trigonometry, we have to label the sides in a specific way. First, we need to know which angle we are considering, and we will label it with the Greek letter theta. H will be the hypotenuse, the longest side of the triangle, the one opposite to the right angle. A will be the side adjacent to the angle, and OP will be the side opposite to the angle. Now we can use SOHCAHTOA, which is a memory aid that helps us to remember the trigonometric formulas. So stands for this, K stands for this, TOA stands for this. If, for example, we know the angle and the opposite side, and we want to calculate height, we need to use this first formula, but we will need to rearrange it to leave h on its own. So h will be the opposite over the sine of the angle. If we want to calculate the adjacent, we will have to use this formula and we will have to rearrange it. So a will be the opposite over the tangent of the angle. If the triangle is a non-right angle one, we have two different methods, the sine rule and the cosine rule. This is the formula of the sine rule that can also be written as this. To apply the sine rule, we need to label each angle with a capital letter, and the opposite side will have the same lowercase letter. The sine rule is a relationship between the size of an angle and the opposite side. Even though there are three relationships in a triangle involving the three angles and their opposite sides, we only need to use two of these relationships at a time. When we apply the sine rule, we will be using one of these three equations. In each of them, only two pairs of angles and sides are involved. For example, in the first one, A and B, second one, A and C, and in the third one, B and C. Or we can also use the inverse fractions. For example, if we have this triangle where we know angle A and the opposite side A, and we also know angle B, and we want to calculate the opposite side, which will be lowercase b, we can apply this formula. We will have to rearrange it to make B the subject, and this will be B. In this other example, we know angle B and the opposite side B. We know angle C and we want to calculate side C. We can apply this formula, and as we did before, we will have to rearrange it to make C the subject, and we can calculate it with this formula. In this last example, we know angles A and B and side C. Here the three pairs of letters are involved, so we won't be able to use the sine rule. Remember, when we apply the sine rule, we focus on just two pairs of sides and their opposite angles. We can also use the sine rule to work out a missing angle, but this time we will focus on the sides. The other method to find out the length of a side of a triangle when the triangle is not a right angle one is cosine rule. This is the formula, and the triangle should be labeled in the same way as we've done before, same letter for the angle and the opposite side. To apply this rule and find out the length of a side, for example A, we need to know the other two sides and the angle between them. Make sure that you label A the unknown side. Also, you can use the cosine rule to find out any of the angles if all three sides are known. These are the formulas that you can find in the booklet that you will get the day of the exam. Here you can see the formula for Pythagoras theorem, and here the formulas for sine rule and cosine rule. You won't be able to find Heron's formula or the other one, 1/2 for AB sinC. So this means that you will need to memorize these two. Now I'm going to show you different examples and how we can find out which method we should use. Example 1. We have to calculate the area of this triangle. It's a right angle triangle, so we have to apply the formula base times height divided by 2. The area is 6 times 5 over 2. This is 30 over 2, so the area is 15. This example is a non-right angle triangle, but the height is known, which is 3. so we can apply the same formula, base times height divided by 2. The area is 12 times 3 over 2. This is 36 over 2, and this is 18. Example 2. We have to calculate the area of this triangle. It's a non-right angle triangle, and the three sides are known. So we will be able to apply Heron's formula. S is the sum of the three sides, 3 plus 5 plus 6 divided by 2, and this is 14 over 2, 7. And the area will be the square root of 7 times 7 minus 3 times 7 minus 5 times 7 minus 6. This is the square root of 7 times 4 times 2 times 1. And this is the square root of 56. So the area of this triangle is 7.48. Example 3. We have to calculate the area of this triangle. It's a non-right angle triangle, and two sides and the angle between them are known, so we can apply this formula. First, we are going to label the parts of the angles. This is going to be A, this is B, this is C. So this angle will be capital C, the opposite angle to A will be capital A, the opposite to B, capital B. So the area is 1/2 of 5 times 7 times the sine of 100. And this is 17.23. Example 4. We have to calculate the length of this side of the triangle. It's a right angle triangle, and two sides are known, so we can apply Pythagoras theorem. The hypotenuse square equals one side square plus the other side square. H square is 5 square plus 6 square, and this is 25 plus 36, 61. So h will be the square root of 61, which is 7.81. In this other example, we also know two sides. We can also apply Pythagoras theorem. H, the hypotenuse, is known. So if we call this side A, we need to apply this formula. A squared equals hypotenuse squared minus B squared. If this is A, and this is B, and this is H, A squared equals H squared, 6 squared, minus 4 squared. So it's A squared equals 36 minus 16, which is 20. So A will be the square root of 20, which is 4.47. Example 5. We have to calculate the length of this side of the triangle. It's a right angle triangle, and one side and one angle are known. So we can use trigonometry. We can apply SOHCAHTOA, and we need to find out which of the three formulas is the right one to apply in this example. If we label all the sides of the triangle, this is going to be the adjacent A, this is the hypotenuse H, and this is the opposite. If we need to find out A, we will have to find a formula that has A and the opposite, this one. So the tangent of 37 equals the opposite, which is 4 over A. We need to rearrange this formula to make A the subject. So A will be 4 over the tangent of 37. And this is 5.31. Example 6. We have to calculate the length of this side of the triangle. It's a non-right angle triangle, and two angles and one side are known. So we can apply sine rule. I'm going to label the sides and angles. This is going to be A, so the opposite side is lowercase a. This is B, the opposite side B. So we are going to use this one. A over the sine of 30 equals B, which is 12 over the sine of 107. If we rearrange this equation and multiply both parts of the equation by sine of 30, we will have that A equals 12 times sine of 30 over sine of 107. And this is 6.27. Example 7. We have to calculate this side of the triangle. This is a non-right angle triangle, and two sides and the angle between them are known. So we can use the cosine rule. I'm going to label the sides, and in this case it's very important that we label A the unknown side. So the opposite angle is A, this is going to be B, and this C. If I apply the formula, A squared equals B squared plus C squared minus 2 times B times C times the cosine of 31. This is 25 plus 49 minus 60. And this is 14. A is the square root of 14. And this is 3.74. Example 8. We have to calculate the area of this triangle. This is a right angle triangle, so the formula that we have to use is base times height divided by 2. But in this triangle, we don't know the height. So first, we need to calculate this side of the triangle, which is the height. So for a right angle triangle, when two sides are known, we can apply Pythagoras theorem, but we will have to rearrange it in this way. If this is A, this is B, and this is H, A squared equals 12 squared minus 7 squared, which is 144 minus 49, which is 95. So A will be the square root of 95, which is 9.75. and this is the height of the triangle. So now I can calculate the area. The base is 7 times the height, 9.75 over 2, and this is 34.125. Example 9. We have to calculate the area of this triangle. This is a non-right angle triangle. We cannot use the first formula because we don't know the height. We cannot use the second one because we don't know two sides and the angle between them. And we cannot use Heron's formula because we don't know the three sides. That means that we need to find out other side of the triangle to be able to calculate the area. I'm going to label the angles to find out which rule we can use. This angle is going to be capital A, so the opposite side lowercase a. This angle B, the opposite side B. And this side is C, so the opposite angle is capital C. I won't be able to use the sine rule because although we know two angles and one side, they belong to three different pairs of angles and sides. The three letters are involved, A, B, and C. And to be able to use the sine rule, only two of the letters can be involved. We cannot use cosine rule because we don't know two sides and the angle between them. But we can calculate easily angle C. We know that the sum of all the angles in a triangle is 180. So C is going to be 180 minus 47 minus 40. So C equals 93. So now we can apply the sine rule because we know two angles and one side that belong to two pairs of angles and sides, C and A. So we can apply this formula. So A over sine of 47 equals 9 over sine of 93. I'm going to rearrange this equation to leave A on its own, and this is 9 times sine of 47 over sine of 93. This is 6.59. And now I can apply this formula because I know two sides and the angle between them. So the area is 1/2 of one side, which is 6.59, times the other side, which is 9, times the sine of the angle between both sides, which is 40. So the area is 19.06.